So, so in this case, we're going to figure out delta H. So again, this is again a change in energy or enthalpy. In this case, we're going to do it by heat of formation. So again, there's a table in the book, an appendix in the book that gives you the heat of formation of each one of these elements or molecules, etc. Couple of things when you're doing heats of formation, what we're going to do in this case is going to be products minus reactants. In most cases, it's products minus reactants. The bond energies was only one, which was the bonds broken minus the bonds formed. But almost everything else, it's always going to be products minus reactants. So look at this reaction right here. I have aluminum, two aluminums, reacts with iron 3 oxide. I form aluminum oxide, plus I give off iron solid. So I'm going to do the products. So it's going to be this right here. I'm going to add up the heats of formation of the aluminum oxide plus the iron, minus now the aluminum plus the iron 3 oxide. When you look up these up at a table in your book, just write down the values they give you. So to form iron 3 oxide is going to be minus 824.2 kilojoules per mole. Aluminum oxide minus 1676 kilojoules per mole. Couple things, if they don't give it to you, it's normally going to be 0. The heats of formation of elements in their standard states or elemental states are going to be 0. Like for instance, now I didn't have this, but if I had O2 gas, that would be 0 because oxygen is diatomic. That's a standard state. That's going to be 0. So some of these will be 0 when you are doing it. So to continue this, I'm going to get the delta H of formation of the products. So again, you look this up. I have 1 aluminum oxide plus 2 irons. Irons are 0. That's the standard state. My aluminum oxide is negative 1676. So this is for my products. And then I do the same for the reactants. 1 iron 3 oxide, that's minus 824.2. I got 2 aluminums, but aluminums are 0. So this is my delta H formation for the reactants. A couple of things when you're looking this up in a table, pay particular attention to their physical states. It makes a difference if it's a solid, liquid, or gas. Like for heat of formation of water in the gas phase, it's going to be different than heat of formation of water in the liquid phase. So pay attention if it's liquid, gas, aqueous, etc. So to finish this up, I take my products. I'm going to subtract from it my reactants. So my reactants is a negative 824.2 kilojoules per mole. So again, negative and negative makes that a positive. When I do this, my delta H of the reaction now is going to be negative 881.51, I'm sorry, 0.8 kilojoules per mole. So again, products and then minus the reactants. The reactants were negative now. So minus a negative makes it a positive. I'm going to end up with 851.8 kilojoules per mole. Whenever you're doing this, they're not difficult, but kind of break it up into the products and reactants and pay particular attention when you're subtracting the two. So I've seen quite a few mistakes with that.